Greetings to everyone. I will be presenting to you our work regarding fusion of General Transit Feed Specification, or GTFS, and passenger count data, a case study on Cyprus transit system. We are the Lab for Transport Engineering of the University of Cyprus, and this work has been performed for the Ministry of Transport, Communications and Works. Our lab consists of Dr. Theocharis Ballis, myself, Dr. Philippos Alodianakis, Dr. Paraskevas Nikolaou, Dr. Katerina Stylianou, and the head of our lab, Professor Lukas Dimitriou. The outline of our presentation will begin with an introduction, then we will move to the data, where we are going to say a few things about the GTFS files and the ITS data that we use regarding passengers counts by stops. Then we will move on to the analysis, where we will see the analysis for the transit network and also the analysis that we took from combining the GTFS and transit demand data. In the end of our presentation, we will get our conclusion. General Transit Feed Specification has become the most widely used transit data exchange format. In conjunction with Open Data Movement, GTFS have promoted the free provision of data to the public. As a result, research around the evaluation of public transport system has boosted. This study fuses publicly available GTFS data with corresponding travel demand data to enable a holistic evaluation of the provided services. This data fusion allows for the simultaneous evaluation of the transit system across multiple dimensions such as infrastructure, network structure, strategic planning, operations, among others, and results in a significantly deeper insight and recommendations towards improving the provided transit services. The main scope of this project is the incorporation of recommendations for enhancing the transit system and increasing the transit mode share. The work, as said before, presented herein regards a part of the meticulous evaluation of Cyprus transit system, which uses the fusion of the two data sources performed for the Ministry of Transport, Communications and Works. The first type of data that we use are the GTFS files. GTFS files is a standard data format developed by Google to describe a given transit system fully. As a result, GTFS files have multiple files with the required information to define the transit network at any given moment during the day. The information is interlinked via common fields across the included tables as shown in the picture. For the analysis, a series of GTFS files for all the cities of Cyprus were taken from the official data repository of Cyprus, which can be found in this address. So here we have circled the different the different types of files we used from the GTFS files, which were routes, stop times, stops, and shapes to indicate the paths. The next type of data regarded the ITS, the data collected from the ITS system. The ITS system was implemented on Nicosia's transit system, which is composed of smart card readers mainly used for fare collection purposes, which can provide precise information regarding the bus route and the stop at which the passenger boarding took place. Our data collection is from July to September 2020, and this is the format that these files have. So we have the route, we have the specific line, which consists of the direction, and we have also the stops and the stop name, and at the end we have the passenger count. So moving to the transit network, here we can see Cyprus's network with the four main cities of Cyprus, where we can see the actual bus stops, and if we can pay more, let's say, attention, we can see the actual routes. So the total bus stops are 4,585, the total routes are 220, and the daily travel distances are 344,102 kilometers. Next, we performed the first analysis regarding the network structure of Nicosia. In the first picture, we can see the density of traversing bus routes through each road link, while on the second picture we can see the density of traversing bus routes through each bus stop in Nicosia. Now, from the first picture, the more depth of the red color, the most links exist among this route. So what we can notice is that there are three main corridors linking the south to the north in Nicosia. However, we can see that there are not as many routes connecting the east to the west for Nicosia. From the other picture, what we can get is that 53% of the bus stops in Nicosia are served only by one bus route, indicating a low resilience to unexpected events of the PT system. This is actually shown here but by the white circles indicated in the picture. Also, we can get from the directionality of the PT links the thing that we said earlier, that the north to south has the most connections. The next analysis of the network structure regarded correlations among bus stops and route lengths and bus stops versus passengers. So here we can see the first correlation scatter diagram, set of scattering diagrams, and here is the second one. What we can see here, each scatter plot is one city of Cyprus. So we have the bus stops and the bus route lengths. What we can see and what we can expect was that positive correlations exist from the number of bus stops and the number of route lengths. However, what we can see is that there are cases such as this of Limassol, where the network has not as many bus stops as it should, and it has a rather lengthier route length. For the case of bus stops and passengers, we can see that there is the only normal, let's say, diagram is this, despite the positive correlation that exists to every one of them. So only for the case of Nicosia, we can see quite a normality on the correlation diagram. The other types show that maybe a better application of demand-responsive transit could be applied. In the next analysis, we analyzed the travel times for Nicosia. So we performed, let's say, an analysis for the different municipality codes to reach Nicosia centers. So here are all the codes, and on the next diagram we can see the passengers' perspective for Nicosia, where we see the municipality codes and we can see the departure times. The colored squares regard the average travel time to reach Solomon Square in hours. Where we see white squares, that means that there is no service at that specific time. So what we can get from this diagram is that a considerable service level deterioration exists after 7 o'clock at the evening, which deprives a large portion of the city's periphery population to participate in social and entertainment activities that are taking place in the center. The next notice that we can make, the next observation, is the fluctuation of service level during the day, where we can see which can cause a deterioration to the public's perception towards specific bus routes and prevent them from using them. This next analysis regarded the coverage. So what we did in this analysis, we want to see the most distant area that can be accessed from a single point of origin with a predefined duration. So we got again Nicosia Center and Solomon Square. So what we did was we used a dynamic routable network formed based on the available GTFS data. These two figures are time-varying graphs, where in the first one we can see the 5 minutes duration, while the second one shows the 25-minute duration. We can understand that 5 minutes the places that can be reached in 5 minutes are much less than the case of 25 minutes. But what this shows is that there is an inefficiency of connecting residential areas with Nicosia city center, which can have a significant negative impact on the utility of. Here we present the data that we got from the ITS system. The first analysis that is presented here regards the years 2018 and 2019. So what we can see is that the demand almost tripled for this year for 2019. Moreover, we can see the breakdown for months, where we can see that the busiest month is October, followed by September, July, May, and let's say June. The next figure shows the weekdays, the passengers per weekdays at each particular time. So what we can see is that we have some, let's say, rush hours at 5 to 6 and at 3 to 4. Also, what we can see for the passengers in weekends, we can see that most of the people use the transport network 1 hour later from the weekdays. So it's at 6 to 7, and we have a much less distributed demand across hours up to 12 o'clock. The demand of the 2020 months was reduced due to the coronavirus that had all the movement restrictions. So what we can see here is the difference between the July of 2020 to the Julys of the other years, and also for the August and September. However, what we can see here is the decrease for July, August, and September with reference of the year 2019. What had happened was that although we had increased cases in July, these cases dropped, allowing for more movement of people. And then in September, where we had increase in cases, then these movements were restricted. Analysis that we can get by fusing the GTFS system and the GTFS files and the data, the demand data, can be presented like these two figures, which are the spatial distribution of demand across bus stops. Here we can see actually the demand across bus stops for the network, where lighter colors represent a lower number of passengers, while more intense colors represent the higher number of passengers. Here we have selected one route where we can see that the most passengers board on the end on the start of each journey, since we have only boardings from our data. Next, we performed an analysis regarding the distribution of demand across bus routes for all the cities. So here we can see that there is a large portion of routes that actually don't have that much of demand, possibly showing that a better design could be reached with a better look on demand. While on the other hand, increased inclination saw a large increase in demand data for specific routes. To conclude, the introduction and efficient operation of ITS systems can have a considerably positive effect on the performance and the perception of the general public towards public transport. Efficient implementation of ITS requires the seamless flow and communication of data, and as a result, transport authorities and agents have developed structured data specification formats to represent the transit system, infrastructures, and operations. The General Transit Feed Specification has managed to become probably the most widely used one globally. However, GTFS lacks the transit demand dimension required for an holistic analysis of the transport network. This study fused multiple GTFS files describing different parts of Cyprus's transit network with the corresponding transit demand data, covering 3 months of 2020 to allow for a comprehensive evaluation of the Cypriot transit system. The obtained results provide deep insights regarding the operations and the structure of the transit network and facilitate the provision of targeted recommendations towards the improvement of the transit system. A key outcome of the study is that data standardization can significantly reduce the burden of amalgamating different data sources and enable researchers to focus on the deeper understanding and improvement of the transit system. Thank you for your attention.